Good morning, I'm Alex Marty with Colton Noble. We're Lab Group 6B, and today we're doing Lab 10, Imaging System Calibration. And in this lab we're going to be taking two camera systems and using MATLAB software to calculate how much distortion the camera systems have and to correct it. And so distortion is a variation in magnification with image field, and there's a quadratic dependence there on field angle. So as you go off axis, if you go twice as far out in field angle, you'll get 4 times as much distortion because of that quadratic dependence. So if we look over here in the center, we have a grid with 0 distortion, and it comes up as just simply a grid. When we have positive distortion, we get this pincushion effect where the center of the image has lower magnification than the outside, and the outside is magnified more. And when we have negative distortion, we have the maximum distortion in the center, and as we go off axis, we get less magnification, and we're going to see that effect in especially in the wide-angle fisheye lens.
Okay, so now we'd like to demonstrate to you guys what a little distortion looks like. And so what I have here is a straight grid checkerboard array that you can tell it's nice sharp edges on the sides, and this is going to be our calibration target for the fast fisheye lens. And so now if I view the fisheye lens, you will begin to see distortion. And so as I move back and forth, you can see that the checkerboard becomes, the edges of the board become curved, not straight. And so this is actually the physical manifestation of distortion that Alex showed you earlier. And so now what we want to do is take multiple pictures of this camera in various orientations, like this, and we'll take these images and we'll actually use an edge finding routine that uses a least descent slope algorithm to calculate what those images look like. And to give you an idea what the fit looks like, you can see how the software that we're using from Caltech actually locates each of the edges of the square. And once it does that, it then calculates the difference in size of each of the squares and where the different coordinates land. And once we do that, we can calculate what the distortion coefficients are. And those distortion coefficients are right here, highlighted in blue for you. And we can see that Kc is the one we're concerned about, and then we get a Kc of about minus 0.495 and 0.2251 in the radial directions. And we get an error of about 0.2 and 0.15 pixels for our distortion correction. Now that we've had a little fun, we're actually going to show you what the distorted pictures look like versus the undistorted pictures. So this is the distorted picture. You can notice that there's a curved edge on the checkerboard indicating the distortion. And so now we're going to go ahead and show you the image that we undistorted. And we were able to straighten out the edge of the target, meaning that we successfully calibrated the camera and characterized the amount of distortion in the fisheye lens.
Alright, we're now on our second camera here, and we see that if we look in the camera's view on the screen, that we don't see the curvature on the grid pattern that we saw with the fisheye lens. And so that tells us that we have relatively little distortion in this lens, and that's confirmed by MATLAB. It showed that there was virtually no distortion. And another cool thing that we were able to do is by taking a cube, we could take a picture of it and we could project out of the one side and out of the other side, and we can read those vectors out of MATLAB, and we can calculate the angle between those two faces, which we'll do in the post-lab. We should expect those to be the angle between those to be about 90 degrees. We also took a slant image that we're going to use to calculate the MTF.
So now we're just going to summarize what we learned today. So today we learned about characterizing distortion in camera objectives and lenses, and this is pretty useful in many fields, not limited to aerial imaging, machine vision, and distortion correction in photography. So what we can do is take these skills that we learned, remove and characterize the distortion in a system, and it allows us to better map and locate images across a picture plane. And with that, that's the lab this week. It's Lab Group 6B, Alex and Colton.